Hello everyone, welcome to my channel. This channel is dedicated to educational purposes, and today is video number 170 on the reciprocal system of theory. And the reciprocal system of theory was first developed by Dewey B. Larson. He started having inklings of this back in about 1930, and he kept at it, uh, working it out inductively for about 25 years. Then he came out with his two fundamental postulates, and from that point he turned it to deduction and if this then that, and developed a theoretical universe that matches up favorably with the real universe. Wrote a lot of books and articles. Right now, we're going to be taking a look at his 1979 book, Nothing But Motion. And we're in chapter 9 of this book called Rotational Combinations. Just a little bit of background. The basic gist of the reciprocal system is that we do not live in a universe of matter, and we do not live in a universe of energy, but we live in a universe of motion. You can see that in the Einstein's equation equals mc squared. Energy can be converted into matter and vice versa. That means that neither one of those two things could possibly be the most fundamental thing. Rather, the c squared part, the speed of light squared, seems to be more fundamental than both of them because it is the thing that converts one to the other. And that's what Larson says. The universe is made out of motion. And motion is the relationship between space and time. We see that in the most basic relation that we know of motion, which is speed. Speed is space over time. 10 miles per hour. 10 miles of space and 1 hour of time. But it turns out that all kinds of scientific phenomena are relationships between space and time. Energy, in fact, is time over space. Matter is time to the third power over space to the third power. Acceleration is time over space to the second power. I'm sorry, space over time to the second power. Force is time over space to the second power. Pressure is time over space to the fourth power, and so on and so forth. Power is 1 over space. And so basically, space and time are reciprocals of each other because they are components of a fraction that is motion. Okay, like just as 2/3 and 3/2 are reciprocals of each other, they have the same qualities, but they are kind of on the opposite ends of the spectrum. So both matter and both time and space have the same qualities. The first of which being coordinateness. They both have 3 or more dimensions. X, Y, Z coordinates in space, and I guess you could say I, J, K coordinates in time. And then you also have what Larson calls clock time and clock space. This is a scalar motion, a motion that has a magnitude, but it has no progression. The flow of time, or the progression of time, time is always getting later and later and later. Same with space. Space is always getting farther and farther and farther apart. And this can be represented using a simple balloon and a magic marker. You put some dots on the balloon with your magic marker, you blow up the balloon, all of the dots are moving away from each other, but they are not moving in any particular direction or all directions at once. And that is a scalar motion. And that's what Larson calls the clock time or clock space, the progression of time and space. And that is one of the qualities of space and time. Also, space and time both come in discrete units only. They are quantized, means that there is no minimum, there is a minimum unit of space and time, and below that minimum, time and space do not exist. Those minimums are very small, and so it appears that they are continuous, but they are not. They come in chunks. And the minimum chunk, 1 unit of time per 1 unit of space per 1 unit of time, is the speed of light. So that makes the speed of light really the background of this universe, or the origin of this universe, half of the 0 point of this universe. This is what Larson calls the natural reference system. Our measurements are made from the speed of light in all directions, outward in all directions. That is the 0 point from which we make our measurements. So half the universe is moving faster than the speed of light, and half is moving slower than the speed of light. This is what Einstein got wrong, where he said that the speed of light was the maximum speed of the universe. He was only paying attention to the half of the universe that's moving slower than the speed of light, which Larson calls the material sector. But he was ignoring the cosmic sector, wherein everything is moving faster than the speed of light, and the speed of light is actually the minimum speed of the universe. And this has to do mainly with mental phenomena, life phenomena, but it also comes into play in the material sector as well. And so in this chapter, Larson is talking about this. There's basically 4 kinds of motion. You have your translational motion, you have your vibrational motion, you have your rotational motion, and you have your rotational vibration. And those can be in 1 or 2 or 3 dimensions. And then you also have combinations of those motions. And that is really how atoms and even subatomic particles get built up, by building up different combinations of motions. And that's what Larson is referring to in this chapter, rotational combinations. They are combinations of different kinds of rotations when he's talking about atoms and so on. Now, he's talking about this inverse here, where we have the speed of light outward in all directions. Larson calls that the progression of the natural reference system. And he's making his measurements from that. Okay, that's the 0 point. So normally you have a 0 point with the legacy science. You have a 0 point, which is complete rest. And then you measure your motion from that 0 point. Okay, the bike's moving 20 miles per hour, 20 miles of time, of space in 1 hour of time from 0. But when you're making your measurements from the speed of light, you're really making your measurements from 1. Okay, this speed of light is 1 over 1, 1 unit of time, 1 unit of space in 1 unit of time. And so you use a multiplicative a scale to measure things up, above, or below that speed of light, in the same way that you would do that with reciprocals of, so if you have 1, if you take 1 step in the positive direction, you get 2. Now, normally, if you're starting from 0, if you take 1 step in the positive direction, you go to +1. If you take 1 step in the negative direction, you go to -1. But if you start from 1, then what you're doing, if you go in the positive direction, you go to 2. But if you go in the negative direction, you don't go to 0, you go to 1/2. It's the reciprocal. So when you multiply them together, you get 1. That is a multiplicative system instead of a additive system. And so that's what Larson is using this term displacement or speed displacement to measure the distance from this progression of the natural reference system. So he's kind of introducing his nomenclature and his terminology for measuring these different motions. Okay, we're going to start right here. Another reason for the use of a distinctive term in designating natural speed magnitudes is that it is necessary in order to make the addition of speeds meaningful. Conventional physics claims that it recognizes speed as a scalar quantity, but in actual practice gives it no more than a quasi-scalar status. True scalar quantities are additive. If we have 5 gallons of gasoline in one container and 10 gallons in another, the total, the quantity in which we are most interested, is 15 gallons. The corresponding sum of two speeds of the same object, rotational and translational, for example, has no meaning at all in current physical thought. In the universe of motion described by the reciprocal system of theory, however, the scalar total of all of the speeds of an object is one of the most important properties of that object. Thus, even though speed has the same basic significance in the reciprocal system as in conventional theory, that is, it is a measure of the magnitude of motion, the manner in which speed enters into physical phenomena is so different in the two systems that it would be inappropriate to express it in the same units of measurement in both cases, even if this were not ruled out for other reasons. It would, of course, be somewhat simpler if we could say speed whenever we mean speed and not have to use two different terms for the same thing. But the meaning of whatever is said should be clear in all cases if it is kept in mind that whenever reference is made to displacement, this means speed. But not speed as ordinarily measured. It is speed measured in different quantities and from a different reference datum. Okay, now just parenthetical here. People, you can get kind of discouraged when you listen to Larson kind of going into what seems to be minutia a little bit, defining his terminology and so on. And, people kind of, I've seen people kind of get upset about that, Larcy's making this so complicated and everything, but you really have to examine this more carefully and recognize that the reason why he's having to do this, it's not his fault. It's the fault of the legacy scientists for giving us all these kind of poison words and poison concepts, and he has to go back and clean that stuff up. He has to go back and help you to unlearn all of the mistaken stuff that you already did learn. Okay, so his theory is not complicated. It's only complicated because we've all got, these various labyrinths in our minds about how things actually are that are erroneous. And so we have to so he's kind of helping us to eliminate the erroneous stuff that we have in our mind already. If we didn't have that, then this discussion would be unnecessary. It would just be, very simple, the way the reciprocal system actually is. It seems to be complicated because he's having to help you unlearn the stuff that you already learned that was wrong. Okay, back to Larson. A decrease in speed from 1/1 to 1/n involves a positive displacement of n-1 units. That is, an addition of n-1 units of motion in which time is unidirectional, while the space direction alternates. Thus, in effect, adding n minus 1 units of time to the original speed 1 over 1. Similarly, an increase in speed from 1 over 1 to n over 1 involves a negative displacement, an addition of n minus 1 units of motion in which space is unidirectional while the time direction alternates. Thus, in effect, adding n minus 1 units of space to the original speed 1 over 1. Space and time are both scalar quantities. They can't be taken together. One of them can have a direction, have a vectorial quantity, but the other can't at the same time. You only can consider really one of them at the same time. As one of Larson's followers, Bruce Perret, has said, we only see space, we don't see time. We see time as its inverse effect in space. And that's where you get things like a white dwarf star, where the star is exploding in time. An explosion in time is seen as an implosion in space. Okay, that's not directly relevant to what we're talking about, but I'm just trying to clarify because I'm trying to get this across, or helping Larson to get this across. In the first edition of this work, the displacements here designated positive and negative were called time displacement and space displacement, respectively, to emphasize the fact that the positive displacement represents an increased amount of time in association with 1 unit of space, while the reverse is true in negative displacement. Experience has shown, however, that the original terminology tends to be confusing, particularly in that it is frequently interpreted as indicating addition of independent quantities of time or space to the phenomena under consideration, whereas, in fact, it is the speed that is being increased or decreased. As pointed out in Chapter 2, in a universe of motion, there is no such thing as physical space or time independent of motion. We can abstract the space aspect of motion mentally and imagine it existing independently as a reference system, what he calls extension space, or otherwise, but we cannot add or subtract space or time in actual practice except by superimposing a new motion on the motion we wish to alter. If we were dealing with space measured from the mathematical zero, it would be logical to apply the term positive to an addition to the speed. But where we measure from unity, the speed of light, the values increase in both directions, and there is no reason why one increase should be considered any more positive than the other. The choice has therefore been made on a convenience basis, and the positive designation has been applied to the displacements on the low speed side of the unit speed datum because these are the displacements of the material system of phenomena. We will find as we proceed that the displacements toward higher speeds, where they occur at all in the material sector, do so mainly as negative modifications of the predominantly low speed motion combinations. Now, again, it's a little bit confusing because we live in the material sector. This is, we perceive the cosmic sector as well, but our primary existence as our body is in the material sector, and the material sector is the slow half of the universe. It's the half that's moving slower than the speed of light. And so if something is moving faster than the speed of light, it seems that you would give it the positive terminology, but in Larson's system, it's given the negative terminology. And so that he's just saying you have to be aware of that. Inasmuch as the units of positive displacement and of negative displacement are simply units of deviation from the natural speed datum, they are additive algebraically. Thus, if there exists a motion in time with a negative speed displacement of n minus 1 units, equivalent to n units of speed in conventional terms, we can reduce the speed to zero relative to the natural datum by adding a motion with a positive speed displacement of n minus 1 units. Addition of further positive displacement will result in a net speed below unity, that is, a motion in space. But there is no way by which we can alter either the time aspect or the space aspect of the motion independently. The variable in a universe of motion is speed. And the variation occurs only in displacement units. The change in terminology has been made in the hope that it will contribute toward a full realization that what we are dealing with are units of speed, even though for technical reasons we cannot call it speed. In the case of radiation, there is no inherent upper limit to the speed displacement, conventionally measured as frequency. But in actual practice, a limit is imposed by the capabilities of the processes that produce the radiation, examination of which will be deferred until after further groundwork has been laid. The range of radiation frequencies is so wide that, except near 1/1, where the steps from n to n plus 1 are relatively large, the frequency spectrum is practically continuous. Okay, we're going to go back to that tomorrow as well, but we'll leave it there for now, and we will take over tomorrow. Thanks for tuning in, and have a great day. Don't get discouraged.